In this video, we will be discussing numbers of different bases, primarily focused on base 10 and binary numbers. Now, base 10 numbers are part of how we think using our modern mathematical minds. When very young people learn to speak, we teach them 1, 2, 3, 4, and so on. And when we sometimes ask them, can you count to 10? We are teaching our children to count in base 10. Since we are taught to speak and therefore think in base 10, understanding numbers and other bases seems unnatural. There is no reason really to think in other bases unless you're a computer. Now, computers think in base 2, and there's a physical reason for this. It's related to switches and electron flow. A switch can either be open or closed, and since base 2 numbers only have two possible counts for each place, that would be a 0 or a 1, computers can store numbers using switches and electron flow to represent numbers. So here's an idea about how it works. So here we're talking about the number 1011 in base 2. That means there's 1 2 to the third, or 8. There's no 2 to the second powers, or 4s. There's 1 2 to the first power, or 1 2. And there's 1 2 to the 0 power, and 2 to the 0 power is 1. So there's 1 1 here. So a computer can represent this by having this third power place turned on, the second power place turned off, the first power on 2 turned on, and then the 0 power of 2 turned on. Now we can write numbers in any base, many bases. We generally think and write numbers in English, or in our modern world really, using base 10. So the number 2000, and see, we have a name for this. We say it's 2000 because there are 2000s, 300 because there are 300s, 40 because there are 4 10s, and 1 because there is 1 1. So that's 2,341 as a base 10 number, and we know what that means. That means 2 times 10 to the third, that's 2,000, plus 300, plus 40, plus 1. Now this number, I don't have a name for it in English. I don't know what to call this. It's a base 5 number. So we would say this is the number 2341 base 5. And what it represents is 2 times 5 to the third power. This is 125 times 2, or 250. And 3 times 5 squared. 5 squared is 25, so there's 3 25s in the number, or 75. So what's that? That's up to 250 and 75 is 325. And then there's 4 5s, that's 20. So I'll have to go back and think about that again. 250 plus 75, that's 325, plus 20 is 345, 346. Okay, that was a little tricky for me. I hope I did that right. And then we have base 2 down here. So the number 1011 base 2 is 1 times 2 to the third, plus 0 times 2 squared, plus 1 times 2 to the first, plus 1 times 2 to the 0 power. So this would be 8, no 4s, plus 2, which is 10, plus 1, which is 11. So in a base 10, as a base 10 number, 1011 would be equivalent to the number 11. Now we can convert a base 10 number to any base we want, really. So as an example, if we want to convert the number 347, which is a base 10 number, we have to start thinking in base 5. So thinking, okay, I'm going to start over here with the 1s. Now there could be some 1s. That would be 5 to the 0, that place. And I'm going to go to the next one. I know there's some 5s, and I'm sure there should be some 5s in there. That's 5 to the first. I don't know how many would be appropriate here yet. What I'm doing is I'm working my way to the left, and I'm thinking about the largest power of 5 that would not be bigger than 347. There's a reason for this. So let's see, 25, I can go bigger. 5 squared is 25. 5 to the third power, that's 125. Let me make sure I'm going to go back and make sure I have that right. 5 to the 0 is 1. 5 to the first is 5. 5 squared is 25. 5 to the third is 125. Now 5 to the fourth is 5 times 125. That's 500 plus 125. That's 625. That's too big. 625 is bigger than 347, so that won't work. So I want to think now in terms of 125s. How many 125s fit into 347? Well, certainly 125 does. If I added another 125, that would be 250. And if I added another, that would be 250 plus 125 would be 375. That's too big. So it must be that there's two powers, third powers of 5 in that number, which is 250. Now that means for the rest of these digits, I have to account for 97, because 250 plus 97 is 347. So now I got to think, okay, how many 25s can I fit into 97? Let's see, 25, I'm counting by 25s. 25, 50, 75, 25, 50, 75, 100. 100 would be too big. So that must mean I can put 3 25s into this number. So I'll put a 3 there. And what's left of the 97? Well, what's left for the last two digits here would be, let me think, that would be 24. Oh, wait, I made a mistake. Oh, goodness. Where did I write down 73? I was just looking at that saying, what on the heck are you doing? All right, so that should be a 75. And that would make this a 22. Okay, let's make sure. I got to be very, very careful here. Now I'm counting by 5s in this place. So I could have 5, 10, 15, 20. 25 would be too big. It's bigger than 22. So that means the number has 4 5s, which is 20. So I have 20. And what's left here for the last digit? There's 2. And then that means there's 2 1s. So the number 347 base 10 is equal to the number 2342 base 5. Well, that's it for this video, so I hope that was clear. If not, please send me a message and ask me any questions you might have.